Let's answer part A. So here we write the function c of x, which represents the total cost of moving x lawns. So we write c of x, and this equals initial cost, which is $250. So we write 250 plus the cost for maintenance. That is, it is given as $5 per lawn. So for x lawns, the maintenance cost is 5x. So we add this maintenance cost to the initial cost. So therefore, the function becomes 250 plus 5x. So this is the total cost function. In part B, we are given that p of x equals 6x minus 250. P of x is the profit function, and we have to determine the revenue function. So for that, we place the definition of profit function. That is, profit equals revenue minus cost. That is, the profit function is p of x. We write down revenue. This can be written as r of x minus cost function is c of x. From this equation, we can determine the revenue function. So we solve for revenue function. That is, we add c of x to both sides. So we get p of x, that is a profit function, plus the cost function is the revenue function. So let's substitute this profit function and cost function here. Profit function is 6x minus 250 plus cost function is 250 plus 5x. And this equals revenue function r of x. Now we can simplify this. We see that negative 250 and positive 250 cancels each other, and 6x plus 5x is 11x. So the revenue function r of x equals 11x. In part C, we determine the number of lawns to mow so that Jimmy makes profit. So here we can use the profit function and set up the equality. That is, inequality p of x should be greater than 0 so that there is a profit. So let's replace this profit function, which is 6x minus 250. This has to be greater than 0. Now we'll solve this inequality for x. So I'm going to add 250 on both sides. Therefore, this becomes 6x greater than 250. We divide both sides by 6. So we get x greater than 250 divided by 6 is approximately 41.66. So this x has to be 42. That is, x equals 42. And this means Jimmy has to mow 42 lawns so that he makes profit.